Everyone, so in this video, we're gonna go over the exercise questions for chapter 4. There are 2 of them. Let's start with the first one. The solar alternative company is about to enter its 3rd year of operation. With the anticipated growth in the business, the founders of the company, Bob and Mary Johnson, felt that they needed a sales forecast to manage effectively in the coming year. It usually takes 60 to 90 days to receive storage tanks after placing the order. The solar panels are available off the shelf most of the year. However, in the late summer and throughout the fall, the lead time can be as much as 90 to 100 days. Although there's limited competition, lost sales are nevertheless a real possibility if the potential customer is asked to wait several months for installation. Perhaps more important is the need to make accurate sales projections to take advantage of quantity discount buying. These factors, when combined with the high cost of system components and the limited storage space available in the garage, make it necessary to develop a reliable forecast. The sales history for the company's first 2 years is obtained. Part A, obtain the time series plot and autocorrelation graph. What do you observe? Part B, fit an appropriate smoothing procedure to the data and forecast sales for 2007. Do these forecasts seem reasonable? Part C, examine residual autocorrelations. Do you think it is likely another forecasting method would generate better forecast? Discuss. All right, so basically we are given 2 years of data. We want to start with the time series plot and the autocorrelation graph. So we will do that in Minitab in a minute and discuss what we observe in the graph, and based on what we observe, we're gonna select the smoothing procedure. Basically, we're gonna choose between simple exponential, double exponential, and the Winters method. Depends on whether we see trend and seasonality. Then we will do the forecast for the 3rd year, which is 2007. And we will try to see if the forecast makes sense or not. Now in part C, we will be examining the residuals by looking at the autocorrelations and see if the method we picked is sufficient or we need something else to generate better forecasts. All right, so let's move to Minitab. And we want to, first of all, copy the data from the Word file and paste it to Minitab. So let me show you one more time this process. So I'm gonna open chapter 4 exercise data, which is shown here. And there are 2 data sets. The first one is for question 1. So when you click somewhere in the table, you will see this little mark there. Click on it, the whole table will be highlighted. So you can do Control-C to copy, and then move to Minitab to paste the data. So I open my Minitab, I can do Control-V to paste the data. Let's take a rough look at the data first before we do the plots. So the time is monthly data. We have 2005 and 2006, 2 years of data. And we have the sales, right? We can see the sales increasing gradually. Let's first examine the data using the time series plot. So let's go to Stat, Time Series, and click on Time Series Plot. Click OK. And the series of sales, so we double click on it, it will be filling in the table. We don't even bother with the variable time. The time is just for our reference, so we know when these data were collected for. In this case, let's put the stamp there, timestamp there, so that we can tell where is one full round of the time, the year, and when the second year start. So I'm gonna double click on time. Click OK. OK again. So there we go. That's our time series plot. So we're interested in trend and seasonality. Let's see. I can tell one thing is immediately is that there is trend and the trend seems to go upward in general in that direction. The second question is, do we have seasonality? This is a little bit tougher because we only have 2 years and one cycle will be 1 year. So we only rely on the 2 years to decide whether the same pattern repeat itself. And that's exactly the reason why I wanted to have the timestamp so that I now can tell from here and to here, that's 1 full year, right? And the rest is the other year. Now I can compare the pattern in the first year with the pattern in the second year to see if they are similar. And the answer is yes, because for the first year, you will see it going up and reach the peak during the summer month and going down for the rest of the year. Similarly, for the second year, the sales is going up and reach the peak around summertime and then going down for the rest of the year. When we move to autocorrelation graph, you will also be able to see that since we have a very small data set, it is almost impossible for us to identify this seasonality using the autocorrelation graph. And I picked this example as the exercise just to let you know that when we work on questions, especially during the lectures, these are questions picked carefully. They're really nice behaved data. And in real world, we will encounter a lot of other issues such as this one. We have small data set and we sometimes need to rely on a little bit more intuition and analysis to pick the best model. All right, so let's do the autocorrelation graph. So we'll go back to set, click on time series, click on autocorrelation. And we're gonna do sales. I did this before recording the lecture, that's why you see something there. If we pick the default number of legs, we only get about 6 legs. And since we know this is monthly data, if we pick 14, we could do that. However, since the data is so small, even if we pick 14 legs, you will see that at leg 12, autocorrelation is not significant and it's not strongly higher than the one before it and after it. So the autocorrelation graph to a certain extent failed to show the seasonality, but we were able to capture that when looking at the time series plot. All right, in terms of trend, the autocorrelation graph does tell us that the lag is declining gradually and also the first lag is significant. So now we confirm there's both trend and seasonality. We talk about several models in class and typically the naive model is not the one. The moving average actually smooth out the seasonality. So that's not useful. And therefore we end up with the exponential smoothing. Among the 3 exponential smoothing, we would pick the Winters method since we've confirmed there's trend and seasonality. All right, so for part 1, if you're gonna answer this question, I'm looking at something similar to the following. We will say, we observe trend and seasonality. Make it bigger. Based on the time series. Since we can tell the same pattern in the first year is observed in the second year. The ACF graph confirms the observation of trend, but can fail to review the seasonality because our data set is small. And that will be the kind of answer I expect for part A. Okay, for part B, we want to run the model we picked, and based on our observation, we will go for the Winters method. So go to stat time series and pick Winters method. The variable is sales. The seasonal length will be 12, okay? We will use the multiplicative model. In terms of the levels, we can try 0.2, 0.2, 0.2, the default as a start, and change the parameters up and down to see what happens. So I'm gonna click on OK. All right. And there's the Winters method model. What I can observe from the model is that our forecast goes along the original data quite well. There are situations where the gap is bigger, like around this region and around that region, but overall it does an okay job, at least. But that's the default level. So let's move alpha, gamma, delta around to see what happens. Let's go back to stat time series and Winters method. I am gonna change level to 0.1 just to see the direction of the model. So click OK, and let's see what happens. Now to choose between these two models, because basically the predicts are very similar. So we're gonna rely on these criteria, measurement of forecasting errors. And for the second one, when we change alpha to 0.1, MSD is around 11.8. Going back, MSD is around 13.5. So that means decreasing alpha make the forecasting error smaller. That's a good move. And we want to see if we change delta, what would happen. So let's go back to time series Winters method. And this is really what's done in practice. In the real world, we do test with the parameters to see which one will give us better result. I'm gonna change trend to 0.1 as well and see what happens. Click OK. And this time it's 10.6. That is still smaller than the previous one, meaning that when I change when I change gamma to 0.1, focusing error decrease as well. So next, what if I change the last one to 0.1? Let's see what happens. So click OK. And it's 10.56 versus 10.61. Still make the error smaller. And you can try a few more combinations to see if you can further minimize the MSD, the measurement while looking at. But I'm gonna stop here for the sake of saving time during this video. And take the last one as the model we want to analyze and verify. Okay, so let's use the last. So let's use the last model to do the forecast for the next year. So we're gonna go back to stat, time series, Winters method, and we want to generate forecast for the next 12 months. That's for the next year. And then click on OK. Let's see what happens. All right, so the forecast for the next year is denoted by this green dots with green lines. And the purple ones are the confidence interval. As expected, we do see the same seasonal pattern in the third year, which should be the case. We also observe that overall the third year sales is higher than the second year sales, which also makes sense. And therefore, we can confirm that the focus from our model, at least based on our visual examination, makes sense, or they are reasonable. So I'm gonna say for part B, we used the Winters method for the data and forecasted for the next year. The forecasts seem reasonable, showing similar seasonal patterns and overall higher sales than previous years in the same season, in the same month. Let me do the month. I need to pull this on this side so we can see it. Just fixing a few typos up there. All right, so that's part B. Now for part C, we want to examine the residues and see if our model is sufficient or not. So let's go back to stat. We need to estimate the model one more time because this time we need the residues. So I'm gonna click on storage and click on residues, click OK, OK again. Okay, I'm gonna have to erase some of the answers so that the screen is not that messy. There we go. We save the residues. Let's get the autocorrelation graph for the residues. So autocorrelation, and we want to do the residues this time. Click on OK. There we go. If you look at the autocorrelation graph, there's no significant autocorrelation. For leg 1, it is close to the red curve, but it doesn't exceed the red curve. So it is not significant and we don't see any pattern. Let's do the time series plot for the residues to double check that. So click on OK. It's not required in the question, but it's always a good practice to check on that. So here we go. That's the time series plot of the residues. The observation to me seems to be random. I don't see any patterns, and therefore we can confirm that the model we picked is sufficient and it does a good job. All right, so that's question number 1. Let's go back to question number 2. So in question number 2, Southdown Inc., the nation's 3rd largest cement producer, is pushing ahead with a waste fuel burning program. The cost for Southdown would total about $37 million. For this reason, it is extremely important for the company to have an accurate forecast of revenues for the first quarter of 2000. quarterly revenue data available for 1986 to 1999. Part A, obtain the time series plot and autocorrelation graph. What do you observe? Part B, forecast the first quarter of 2000 using a moving average method. Part C, forecast the first quarter of 2000 using a smoothing method. Part D, evaluate the forecasting methods and determine the best method. Part E, examine residual autocorrelations. Is the method adequate? So basically, this question is similar to the first one. The actual step we need to do is to perform a forecast using a moving average method as well. Let's go ahead and start the analysis. And this time, I'm gonna just copy the data and paste it to Minitab behind the scene. So here we go. I just pasted the data. The first column is time, and the second column is the revenues. We will start with the time series plot, and therefore we're gonna go back to stat, time series plot. Click OK. And then this time the series will be revenue, double click on it. I still would like to put the stamp there, but this time the stamp, well, still named time. So I'm gonna click, oops, double click on time to fill in and click OK, OK again. There we have the time series plot. And remember, this is quarterly data. Similar to the first question, I see two things. The first is this trend going up slowly at the beginning, but then start to speed up towards the end. I also observe seasonality because I see very strong patterns within the same year. That is, every 4 quarters, the pattern repeats itself. So let's use autocorrelation graph to double check. We're gonna go back to stat, time series, and autocorrelation. We will pick revenues. We can return to default number of lags. In particular, since this is quarterly data, as long as we have 8, 10 lags, that should be enough. So I'm gonna click on OK, and 14 lags were reported. So let's get rid of this. Let's see. First of all, I can definitely observe the trend because the first 4 lags are significant and they are decreasing gradually. We can also observe seasonality because for the 4th lag, when I draw this curve to kind of follow along the declining pattern, the 4th lag standing out, right? The 4th lag is almost higher than the 3rd, but much higher than the 5th one. And similarly for the 8th lag, it is virtually the same as the 7th lag, but much higher than the 9th. And we can see this very clearly for the 12th. And therefore we can confirm both seasonality and trend within the data. All right, so for part A, we will say the answer actually turns to be similar to the first one. So we observe trend and seasonality in both the time series plot and the ACF graph. The lags are the first, I'm gonna say the first 4 lags are significant, and the lags are decreasing gradually, meaning there is trend. The 4th, 8th, and 12th lag are all equal or higher than the one before and the one after. actually, I'm gonna say the ones, and thus confirm seasonality. All right, so for part B, we want to use the moving average to do the forecast. Let's do that. So we'll go back to stat and time series, and we're gonna pick the moving average. The variable is revenue, and we need to define the moving average length. Apparently, since this is for quarterly data, we will pick four period moving average because the pattern repeats itself every 4 quarters. So I'm gonna click on OK. And actually, before that, we do need to generate forecast because the question says we want to forecast for the first quarter of 2000. So we're gonna forecast one step ahead. That's 1 quarter, the first quarter for 2000. So put 1 here, click on generate forecast. Now click OK. And there we go. We have the forecast from the moving average plot. Okay, we can see that for the first quarter of 2000, the forecast value is 318, and with a interval of 250, around 250 to 388. Okay. Part C, we want to use a smoothing method to do the forecast. Since we've identified there's trend and seasonality, we're gonna use the Winters method. So let's do that. Go back to stat, time series, autocorrelation, revenue, and pick the Winters method. So it's revenue, and the seasonality turns to be 4 this time. We will still start with the 0.2 default level, and we will generate forecast for 1 period only. I don't know yet if the parameters are the best one or not. So this is just a start point for us to go with. So click on OK. And this time the forecast turns to be 297. That is different from the previous one. And the interval goes from 254 to 341. Okay. Now, if we look at the graph right here, apparently the Winters method mimic the original data much better than the moving average method. As you can see, the moving average really get rid of the seasonality. And therefore, we can even tell from that, the forecast from the moving average will not do a better job than the Winters method. You can't get rid of the seasonality because seasonality is an important component in the data. All right, from the Winters method, MSD turns to be around 700, but from the moving average method, MSD turns to be 12,048. That is much higher. All right, but we just started with the default level alpha, gamma, and delta. We should try a few more to see if we can get a better model. And in practice, actually, we will try a lot more to get the best model as far as we can do. And because forecasting is very important in terms of making business decisions. And as long as there's room for us to improve, we want to take that opportunity. In terms of your work, you may ask, so how many times do I need to try? I don't want to give you a specific number and say you have to try 10 times. But as a minimum, this is my expectation. The default levels, 0.2, 0.2, 0.2, rarely is the best option. So I do want you to try to change alpha, gamma, and delta up and down a little bit to see if you can improve MSD. At the end, for the results you report, I want you to report the best combination of alpha, gamma, and delta. And if you report just 0.2, 0.2, 0.2, that to a certain extent suggests you didn't try other models or you didn't try enough runs to make it better. So for that purpose, let's change alpha, gamma, and delta and see what happens. This time I'm gonna do alpha first, same as last time. So Winters method, and let's see, we're gonna pick alpha equal to 0.1. It's 12, 12. Apparently we don't want to decrease alpha. So let's try alpha equal to 0.3 instead. And that gives me 619. Apparently that's smaller than the basic ones. I'm gonna just call this the default one or the baseline, right? So when I change alpha to 0.3, that is better. And we're gonna do the same for gamma and delta, changes up and down to see which one can give us better results. And without showing you every model that I tried, I just want to show you the one that I kind of settled down with. So what I did is I increased alpha to 0.3 and decreased to 0.1, increased gamma to 0.3, decreased to 0.1, increased delta to 0.3 and decreased to 0.1. Eventually, this combination seems to give me the best results so far. And this is also what I expect from you. I don't need you to follow exactly what I did, but overall, I do want to see you testing on different combinations and do not report just the combination of 0.2, 0.2, 0.2. These numbers should change to find the best one. All right, so we're gonna use the last model for our answer to the question. And part D says evaluate the forecasting method and determine the best method. So we're gonna say, based on the MSD, MAD, and MAPE, we can tell that the Winters method does a much better job than the moving average method. The parameters for the Winters method is 0.3, 0.2, and 0.1. And that is the answer to part D. Part E, we want to examine residues. Is the method adequate? So apparently, if we decide Winters method is the best, that's the residue we want to examine. Let's go back to stat and time series. We're gonna do autocorrelation for the very last residue. That's the last model we picked, and that's the one we want to go with. So I'm gonna do okay. All right, so that's the autocorrelation for the residue for the last method. Surprisingly, this time, it turns out the method is not quite adequate because we still observe a significant autocorrelation for the first leg, meaning that there's still some pattern or feature we can use to better focus for the data. So for part E, we're gonna say, by examining the ACF for the residues, we find that the autocorrelation for the first leg turns to be significant. This means that there's still certain systematic pattern that is not fully captured by the Winters method. We should consider other models. All right, so that's all I have for this exercise. Let me know if you have any questions.